Dear student, today we are going to show that sum of nilpotent elements is a nilpotent element in a commutative ring R. But in order to understand it, we are supposed to know what exactly binomial theorem is. So let us try to understand it. Now we already know what is expansion of a plus b raised to 2. So by binomial theorem, this expansion is nothing but a square plus twice ab plus b square that we use all the time. Now what is the basic reason behind it? So logically a plus b square is actually nothing but a plus b multiplied by a plus b. Now we are talking it in terms of ring theory, right? In ring theory, a raised to 3 is nothing but a multiplied by a. Similarly, a square will be a multiplied by a. So a plus b square can be written as a plus b multiplied by a plus b. If you solve it, then we observe that it comes out to be somewhat like this: a square plus ab plus ba plus b square. But as we know that this ab need not be equal to ba in ring theory. So when AB will be equal to BA if the ring is commutative. So if the ring is commutative, then this will be exactly equal to A square plus twice AB plus B square. So in general, whatever the binomial theorem we use, that holds in the ring if the ring is commutative. Now this will be required in order to prove that the sum of two nilpotent elements is a nilpotent element, and the important condition that is given to us that the ring is commutative. So as the ring is commutative, we can use the binomial theorem in this particular ring. So as we know, by binomial theorem, what is the expansion of a plus b raised to n? So the expansion is summation r is running from 0 to n combination r, a raised to n minus r, b raised to r. Now this will be needed in order to prove this. Now as we have said that a and b are nilpotent elements. Now what is the meaning of nilpotent element? There will be some positive integral power of a which will be equal to 0, and the same thing will happen for b. Thus I will say there exist natural numbers m comma n belonging to n such that a raised to m is equal to 0 and b raised to n is equal to 0. Let us call it as sum 1. Now in order to prove a plus b is nilpotent, we have to show that some positive integral power of a plus b is equal to actually 0. Now in this case, the power of a plus b we are going to take as the sum of the powers of a and b on this side. So actually we have to prove that a plus b raised to m plus n is equal to 0. So I will consider a plus b raised to m plus n. But by binomial theorem, what will be this expansion? Remember, this binomial theorem is true because the ring is commutative. So this is equal to summation r is running from 0 to m plus n combination r, a raised to m plus n minus r, b raised to r. Now here we are going to make two cases. The first case is we will assume that the value of r is actually greater than n, and the another one is if value of r is less equal n. So I will say if r is greater than n, then what will happen is this b raised to r can be written as b raised to n minus r, r minus n multiplied by b raised to n. This is simply by laws of indices that we can use in ring theory. But note that whenever we are having b raised to something or an element raised to something in ring theory, I mean an element raised to an integer, that integer should be positive, because in ring theory we are not sure whether the inverse exists with respect to multiplication or not. And what is a guarantee that the power of b is positive here? Since r is greater than n, right? Now we already know the value of b raised to n, so we can use it. So this is actually equal to b raised to r minus n multiplied by 0, and which is equal to 0. Now the another case, if r is less equal n, then what will be the value of a raised to m plus n minus r? So this will be actually equal to a raised to n minus r multiplied by a raised to m. Now the same reason, again we are having a raised to integer here as well. No issues for this because m is already a natural number. Now a raised to n minus r is there, but it is also going to be a non-negative quantity since we are assuming r is less equal n. Now we already know the value of a raised to m, that is 0. So this will be a raised to n minus r multiplied by 0, and this is actually equal to 0. So what we have shown here is if r is greater than n, then b raised to r will be 0, and if r is less equal n, then this quantity will be equal to 0. In other words, all the terms in this summation are going to be now 0, and therefore this a plus b raised to m plus n will be actually equal to 0. So let us call it as 1, 2 and 3. So using 1, 2, 3, what we have shown is a plus b raised to m plus n is actually equal to 0, and therefore a plus b is nilpotent.